morning, everyone. I'm so happy to see so many of you this great morning, the last day of DevOps. Have you had a good time so far at DevOps? Have you had coffee this morning? Are you excited for one more day of DevOps? That's what I want to hear. Thank you so much. Well, so the topic of today that I have for you is called dealing with JSON in the relational world. The idea of this session is to showcase some of the things that you have to have in mind if you want to use JSON documents and relational databases. There's going to be more than one. And there will be other features that you can use in order to store JSON and to make use also of relational data together with JSON documents. Now, I will suspect that most of you have to deal with a database at some point in your time. Is that correct? So raise some hands. Yeah, like almost everybody in the audience. Perfect. So my name is Andres Almiray. I'm a senior principal product manager at Oracle. I'm also a Java developer. That's why I'm here, because I like to talk about many different things. I like to talk about open source. I like to talk about many of these technologies that excite me. And well, dealing with the database is something that we have to do at some point in our lives and our daily work. And there are many different options at our disposal. So, JSON, that's the main topic. If in case that you didn't know, databases, RDBMs, are more than just storage. I think that, well, I can speak for myself. For many years, I used to think that the database, it was something that I've just dumped data and then retrieved data and nothing more than that. But it turns out that databases can do more than that. So they take care of scalability. You can shard the data. They can do authentication. They can do, you have observability. They have this thing called the multimodal, which allows you to store the data in different formats under the same database engine. Say, for example, if you want to do documents or column-based or spatial or geo or again relational, any kind of NoSQL, you could have different products to deal with each one of these separate data formats, or you can have one single product to do all these things. So this is called the multimodal. So again, RDBMs can do many things, and we can treat them as more than just dumb things where we can store the data. But for today, even though there's so many things that we can do with them, we are just to concentrate on the multimodal aspect. Because again, one thing that we'd like to do is to deal with different representations of our data inside the same database engine. So I'm going to discuss these different database providers. It's going to be MySQL, Postgres, and Oracle. In the case of Oracle, when we talk about multimodal, we like to call it the convergent database. This is the one that allows you to have JSON, and even we also have now a vector support in the latest version of the database, 23 AI. You have obviously relational data, and you can have graph and spatial, so many things. So Oracle is not the only one that does it, but I believe is the one that provides the most formats under the same roof. Another thing that these vendors, as well as Oracle, allows you to do is to query across all these different formats using one single query language. In the case of Oracle, it will be SQL, and some of these queries that you can write with SQL will have extensions to it. So yes, you can have a table with relational columns and a vector column and JSON column and some other kind of formats and do a query across all that. And you can also have multiple tables, again, with different formats and do a query across all those things. So all these vendors will give you access to that. Additionally, in the case of Oracle, we supply other, let's say, other technologies, other projects on top of the database that are accessible to you for free. Some of them are open source as well. So for example, there's Apex, that is a low-code option that allows you to create applications very quickly with just drag and drop and a little bit of pieces of code. The SQL CL, a command line tool. There's SQL Developer that runs on standalone or as an extension on VS Code. So yeah, there are many options that you can have access to. But anyway, so why would you like to store JSON in a database? That is the question. Well, one of the great things about JSON is that you can evolve very easily what is the schema of the document. As a matter of fact, you may start with something that looks like it doesn't have a schema, because a JSON document is simply a collection of key value pairs and nested objects as we go. It also has arrays, obviously. But when you look at the definition or the structure of a JSON document, it can be mapped very easily into our programming languages of choice. In this case, it will be Java, most likely. So in the definition, on the one side, you have a JSON document with certain properties. Those properties can be mapped directly into Java fields. The top level document could be just a regular Java class. If we happen to have nested objects, then those will be other Java classes, and we can have arrays of all these basic types. Great. So this facilitates our job when taking information coming from the client side, whether it's the browser, whether it's a mobile, whatever, what have you there, and that just go directly to sending that data to our application layer, pass it through our POJOs, do anything that we have to do that, store it, retrieve it. You know how it goes. So I guess most of you know JPA, Hibernate, Eclipse links, all these little things. Perfect. So this is exactly what we want to do. Now we use JSON nowadays because it's quite ubiquitous. In the past, we used to do XML. Does anyone still remember sending a POX across the network, a plain old XML object, right? Now everybody, the kids use JSON. So when you are dealing with JSON documents, you have choices. You can use a collection API or a document API to grab information or manipulate data from a document, which is one you see on one side of the screen. Or you can also use SQL statements like in the other side of the screen, where you think that, yeah, you can use projections. You can navigate the graph of properties inside a document just using the dot notation. So it's not like you only have one choice. You have at least two choices. That's good. Now, storing JSON in a relational table can be done in a couple of ways, depending on the database provider that of your choice. Say, for example, if we want to store a JSON document as is and dump it directly into a relational table, well, we can use varchar, which has some limitations. We'll see that in a moment. Or you can use a character love, which has a restriction in the size. Or you can use a binary love. Or you can use a JSON type directly. So in the case of varchar, we are limited in the number of bytes that we have access to. We are limited also in the format. If you want to use more space, then you probably have to jump into character love or a binary love. Again, we also have restricted in some space. But the things about these different options, again, whether you want to go with MySQL, Postgres, or Oracle, is that when you store JSON documents in this way, they are like an opaque thing. That is, you get one single document and then you store it directly. And if you want to look inside that document and do some queries, for example, grab a document where the ID of the username of the given user is this and that, or navigate the relationship that you may have inside the properties, the only way that you can do this is by retrieving the whole document, so reading completely from the database, and do some sort of manipulation at the application layer. And if you need to do any updates to that document, again, you have to grab the whole thing, use perhaps JSON if you are at the Java layer, and change the document, and then store it again. There is another option that we have access to, which is the JSON type. The JSON type was added to the SQL standard. I think it was added 8 years ago in SQL 2016, which gives you access to storing a document in a more efficient way. The different database providers will have different implementations on how they want to store the JSON. Most of them have chosen a binary format, but it's not the same binary format for all of them. There are different variations, and we'll cover some of those here. So because they have been optimized for different use cases. So there's no way that I can tell you right now this or that will be the best format. It depends on your use case. So when you want to combine the use of JSON data and SQL data, these database providers will give you access to something like this. So you define a relational table just in the same way. And the thing that is different here, the thing that you've noticed, is that now we have a specific JSON type. Again, this JSON type will be implemented in different ways depending on the database provider of your choice. Now, the advantage of doing this, again, what I mentioned before, is that now it's part of the SQL standard. So when this was released in 2016, the earliest providers, I think I have a slide later about a particular blog post that showcased what is the current state of implementations of JSON for the different database providers, which is actually this one. So this is just one of the graphs. There's a link here on the slides where there's a list of everything that was exposed at the time. Again, this was done in 2017, so it's a bit, I wouldn't like to say old, but it's been 7 years already. So very likely that these database providers have had much better support since then, so it would be a good idea to have a reevaluation of this particular report. But in this way, you can see what is the current state of JSON support in different formats, in different ways, the different functions that you have access to that you can call directly from SQL. For example, if a JSON value exists, or you can retrieve a JSON value using the JSON underscore value, you can issue a JSON query like something like XPath, or you can grab a value of the document looking at a JSON table. There are so many things that you can do here. So given that we have access to JSON directly on the SQL standard, these are the things that we can do. So the query on one side uses the dot notation to navigate the relationship that you have from the root of the document, which in this case will be the data column. And then we see that it has a property called budget and another property called studio. And we can cast the values of these JSON properties into a specific data types, because again, a JSON document is just character data, but some of those fields, some of those properties we would like to be interpreted as a number, as a string, as a Boolean, or something else. So we have access to these functions, a number, a string, and whatnot, to ensure that the data that we're reading is coming in the right type. Or we can use JSON query, which some of you that may have seen MongoDB, this looks like quite similar. Or we can use JSON value to retrieve a specific data point inside our document, again, navigating perhaps the relationships that we have inside our document. And we can apply many other functions here. So, in terms of implementation details, Mongo, Postgres, MySQL, and Oracle use different binary formats. And some of them optimize for streaming, some other optimize for space, some other optimize for read. So it depends on the kind of data that you have, the volume of data, the SLAs that you have in your applications, that you will go with one or the other. My recommendation that I have for you at this point is, if you are unsure on which one you should go with, then do a proof of concept. Run a POC on all these different providers with your real data, and then you figure out. Obviously, I have a preference. I believe that Oracle would be the best choice in most of the times, but to be really honest with you, you are the one that have to do the evaluation. Okay, so in the case of Mongo, they added support for binary JSON, well, since the earliest stages. They support pretty much all the data types for JSON. They do support additional data types through an extension. And the important thing about this particular format is that it does support streaming of values. So that is one of the advantages. So you can continue to just consume values or information from the document as you go. You don't have to read the whole thing, you just can read it on chunks. Now, the strange thing, I don't know exactly why they decided to go with this one, is that arrays are actually implemented as structs, where the keys are the indexes of each one of the elements. The other binary formats do support arrays. I guess it's a matter of dealing with the space. And the interesting bit is that you have client-side encoding and decoding. That means that the consumer, which is the application layer, have access to reading the binary format directly from this data storage, do not do any kind of conversions on the fly, and once I have it here at the application level, I can start do the actual decoding. So the application consumes the binary directly. It does not consume something that is already transformed from binary into character data. So that allows for passing information much quickly within the two layers, persistent and application, and only decoding data when I need it, not eagerly. Okay. In the case of MySQL, they have another binary format called bJSON, and it was introduced in MySQL 5.7. It does support all the scalar values for JSON, so in this case, we're quite on par. It does support additional data types using some custom extensions as well. The implementation of the format is different. It's a table of pointers with key value pairs. The pairs are sorted by key lengths and then alphabetically sorted. That means that you have like a dictionary of the keys based on how long they are in terms of the size of the number of characters. And once you have that, they go alphabetically. Why? They chose to go with that way. You can do partial updates. That means that you will be able to, again, from the application level, consume the binary directly and change some portions of the content without having to read the whole document. In the case of Postgres, so the one thing that I want to say that bJSON is on quotes because we don't have an official name for the format. It's just binary JSON. In the case of Postgres, it's JSONB. I think that this started with a proof of concept on FerretDB. Now, this was added yet again as another set of extensions. At the time, I think it didn't come out from Postgres, from core Postgres. And that this is similar, the implementation, the format is very similar to MySQL. Again, it's just a table of pointers for key values. The keys are sorted by length and also then sorted alphabetically. Now, there is one of these two formats that kind of have a little bit of trouble if you have duplicate names. Say you have, at the root of your document, you may have a name property, and somewhere along in the structure, you have another nested object that also happens to have a name key. Well, from the point of view of the format, these two name properties are duplicate, even though they belong to different elements, different domains within your document. And then finally, we have the Oracle format, which we call OSON. Again, it's also binary. It was added in the Oracle 21C, which was released in 2021, backported to all their versions, so you can run it on premises or on the cloud version, and obviously available in the latest release, which is 23 AI. Now, the difference in the format is that we have a header that also includes the version. I believe that out of the 4 different versions or the different formats that we have and so far showcasing this session, this is the only format that includes a versioning aspect. So that will allow you to detect at the application level if you're dealing with an older version of your definitions or if you're dealing with a new version. We have a dictionary of field names, so it's easier to deal with the duplicates. The values are stored as a tree, and this gives us a better advantage, I believe, with compression. So we'll see that in a moment. We also support client-side encoding and decoding, again, for the same reason. So you consume the binary directly at the application level instead of just reading character data. Now, a little bit of comparison among the different formats. So how we store information in the different formats will give us a measurement of how much space we will have to use for each one of the data types. Null and booleans are pretty much the same, so no surprises there. But in the case of the integers, we start to see a little bit of differences. And at the time, Postgres stores most of the data using strings, whereas the other binary formats do have a specific byte representation. Some of them are a bit bigger, some of them are a bit smaller. So depending again on the volume of data that you have to deal with, you will have to make a choice whether you go with one particular vendor or you go with the other vendor. Now, some of these formats support the data types as they are. Some others, specifically for timestamps at datetime, you have to use extensions or you have to deal with them in a different way. In the case of capabilities, the JSON format from MongoDB is the one that keeps the field ordering, and they have to do this for the streaming, whereas the other binary formats do not keep that, so you can access the data from in any kind of order you want. I mentioned that Oracle is the only one that at the moment does support a version tag in the format, so you can tell which kind of version you're using with. It supports or provides the dataset types. That means more than just the JSON data types. Pretty much everyone except for Postgres supports additional data types, very easy to hook into. The possibility to evolve the format. Mongo does support extensions. The binary format for MySQL, it's possible to do it. At the time, Postgres can do it, but it's not that easy. And in the case of Oracle, we thought that, yes, it does make sense to have this feature from the early start, so we do it. The maximum size after encoding the document varies across the board. So we start with 16 megabytes all the way to 255 in Postgres. And in the case of MySQL, well, it's 1 gigabyte. That's plenty of space. Oracle is 32. Client-side encoding, both Mongo and Oracle support this. So that it means that it's more efficient where you're reading the data at the application level. Sadly, MySQL and Postgres does not. So there will be some sort of translation, conversion of the data before you actually can consume it. The ideal encoding size, well, it depends on the size of your document. So if your document fits within that particular window, then your application will behave much more effectively. But of course, you can address a document that is bigger than size. It's just that it's going to take a little bit extra time to deal with it. Mongo is the only one that can do a streaming at the moment. If that is a key feature for your application, then perhaps Mongo is the database provider of choice. Oracle, Postgres, and the binary format for MySQL do support a dictionary format, so it's easier to find out what are the properties of the document, whereas Mongo doesn't, because it's streaming. It has to do it as you go. Compression algorithms, it's a wide variety across the board. In case of supporting duplicate fields, both the binary format for MongoDB and Oracle do support this. The binary format for MySQL and Postgres do not, again, because they sort the keys in size first and then in alphabetical order. So that gets you in trouble with duplicate names for the fields. Partial updates, pretty much everybody does it. Some of them with a little bit more trouble than the others, but it's a feature that is provided by everyone. And yep. So this is what happens with MySQL and Postgres at the moment, which is when you are reading data from the database, at some point before it reaches the application, it's going to be translated to whichever format it is, which is, again, binary, into UTF-8 character data. And once it's done, this is part when the driver accesses it. When it goes back into your application, once you are at the JPA level or the higher levels, you have a JSON document that can be translated into POJO classes, do whatever information, whatever behavior you have to do with this set of data, and then decide if you want to store it again or send it to the client. So the problem here is that we have two transformations, from binary into character data into Java objects. But if the client side is able to natively read the information, then we retrieve binary from the database into whatever structures that we have here at the application level. And as we need it, we can read the properties from that binary format into the Java fields that we're going to make use of, entities, whether it's a Spring Boot, Quarkus, Micronaut, Helidon, what have you. There are so many different choices. But the advantage here is that the database providers that give you access to consume the binary format directly do not force you to do transformations of the data that are not needed or read as much data eagerly if it's not needed. So some of the best practices that we could recommend in case of using the different database providers, depending again of the size of your documents, you have better performance. If any of these numbers have changed recently, I would certainly encourage you to go through the documentation of each one of the database providers to see if the document size is different so that you can properly size your information. And if you know that if you are beyond the optimal size, then your SLAs and your performance will be different. One more time, I want to remind you that Mongo is the only one at the moment that performs streaming. The others do not. And time zone is easy, it's kind of easy in MongoDB and Oracle. The others have a little bit of trouble. It's a little bit more elaborate. So the slides will be available for you later, so you can do you can follow up with the different comparisons. Yeah. Okay. In the case of the Oracle database that we support Ozone, we also allow you to store, well, as I said, it's JSON and relational, but we also support vector database, vector types from the start. And one of the great things about vector support is that you can read the whole vector as is instead of reading it as an array. So it's a single value, and you can manipulate it. You can manipulate it as you deem necessary. We also support MongoDB API integration, which means that you can hook in an Oracle database as part of a Mongo cluster, and that Oracle database will be seen as if it were just a regular Mongo node. And there's a Mongo compatibility layer, so you can issue Mongo queries to the Oracle database. Why would you like to do this? Well, when was the last time that you created reports using documents? Was that an easy task? Not so much. But it's easy task if you do this in a relational format, right? This is what we're doing for decades. Well, the advantage of the MongoDB API is that from the point of view of the consuming application, the storage looks like Mongo, but it's actually relational. So all the tools that you use in the relational world will do their job with the data that you're storing, but your application will continue to work if thinking that the storage is just any other Mongo node. Now, for a longer and a better comparison of these different formats, there is a video of a session that one of my teammates did, Log Lefebvre, on the different formats for these vendors. But what I like about this particular video is not that it's been done by one of my teammates, but because he also wrote a Java tool to visualize the differences within these formats. So you have a document with a particular set of constraints and structure, and that document will be stored using each one of these 4 formats, and you will see where the keys are lying, where the different values will go, and if it mutates the document in one way, then the properties and the fields and the values will move around. So it was much easier to understand the differences on the choices that were made for each one of these particular formats. So highly recommended to have a look at this one. It's less than an hour, and I don't believe that the tool is open source, but it's something that will be recommended to keep a look at when is the time to, if that tool gets released. Anyway, so moving on into Document API, we now think, yes, it's a good idea to store JSON in the database. We know we can use different data types within a relational table. whether it's varchar, clove, clove, or the JSON explicit data types. So once we're dealing with JSON inside our relational tables, we can have access to it in a couple of ways. You can use standard JSON queries. You can use JSON collections. You can use document APIs. Again, all these different vendors will give you access to similar ways to query these things. In the case of Oracle, we have an API called Simple Oracle Document API, SODA for short. There's a REST version and there's a Java version, and both of them are available as open source projects for free. You can go into the Oracle GitHub organization and just search for SODA, and you will see there's an open source project out there that continues to push out updates on how you can access documents through the Oracle database. But we can do things better, because so far you may have been seeing that, yes, I have a JSON document, I can then put it in a database, and I have relational data, I have geo and something else, but these things are a bit separate. And when we are having relational data and documents, at some point you probably have seen that you may have seen that you're using JSON or JSON to transform an object graph of Java types into documents, and also use that object graph into the persistent layer, where it's again JPA or the freshly announced and released Jakarta data or Spring data, Micron data, what have you, right? So we have two different things here. Would it be better if we have a unified way to deal with both documents and relational? So this is kind of the idea that some people at Oracle started to think about. Hey, it's so ubiquitous that we use JSON to communicate with the client applications on the browser and the mobiles. Wouldn't it be easier if we had a way to grab those documents and insert them directly into the database, but at the same time giving you all the benefits of the relational world? So let's start with this. Say, for example, that you want to do, or you need to create an application that models a conference. So you can define as many entities. We can start with simple ones: the attendee, the session, and the speaker. Each one of these entities will have different relationships. There's a standard SQL, and then each one of the entities will have its own properties. And because of the nature of relationships, there's the primary keys and foreign keys. Yes, we know this by heart. This is how we do relational data. Okay. The advantage of this is that we have no data duplication. The data is normalized. We have many tools that understand this, yada, 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 migrations. This is a well-understood world. Great. The problem with this is that we have to decide very upfront how the schema should look like. Which are the names of the tables? What are the relationships within all these different properties? If we made a mistake, then we have to come, or we need to modify later the definitions of our entities. Then we have to come up with these things for database migrations to ensure that these migrations are invoked at the right time, and we have no downtime of our applications. And there are some other considerations that we have to take into account. Right. Okay. So if the application that we want to write is something that provides like a condensed view of all these different tables, so kind of like a schedule that consumes all the different tables, great. This is something that we want to provide. The idea will be, hey, let's grab the data directly from the database and then just dump it into the client without much transformation. That is what would be great to have. But what's actually happening is that we have to talk to different tables and assemble that data and then send it to the client. If we were to deal with documents, then we can come up with different schemas based on the same basic tables. So it could be the attendee is the root of the document, and we have nested objects for the session and the speaker. That's one possibility. Or we can have the session be the root of the document and have a speaker and attendee nested at the same level. So you can see that the speaker and attendee share properties within the same nested object. Or it could be just the speaker and the session. It's up to you. The advantage is that it's the same data in relational way, but in a different representation if we look at it in the document way. Now, the good things about JSON is exactly that. We can we can define the root of our document to be anything we need to. Even for different clients, we don't have to store it in different ways. We store it in one way, and we just expose it as we need it for the mobile version or for the browser version or for a different edition for one of these things. That's great. However, depending on how we do the nesting, however we do the reference within our entities, there will be data duplication. And that is kind of like a big no-no when you're dealing with the database, at least in the relational way. So can we normalize JSON? Yes, of course we can. We can do something like this. We can add IDs to our documents, so we can have a reference from one entity to another entity, and we keep doing that, and we keep doing that, and we end up with the worst of both worlds. We have normalized documents, we have fragments, but what used to be easy to read from a developer's point of view is a document that is easy to understand. Now we have to navigate relationships in this way. It's not easy for a developer to understand this, but also, yes, of course, machines are able to do the relations quite quickly, but now we have to deal with fragments of documents instead of just one single bit. Well, not exactly one bit, but one single piece of information. So yes, you can normalize JSON, but the simplicity gets lost. And if you have big documents, then it will be very difficult to understand and debug and to test these things. So yeah, don't do it. If someone has asked you to add IDs, multiple IDs to your JSON documents and do some sort of normalization, that's not the way to go. Anyway, JSON allows you to have very, very quick experience in the early days of your application. It's so easy to get started. You just create a schema as you need it. You evolve it also as you need it. Off we go. But as your application grows in complexity, dealing with these schema-less documents and a bunch of JSON documents lying around in your system, it starts to give you more headaches. In the case of relational, there's a lot of work that we have to do upfront. There's a lot of things that we have to think early on in order to make our lives easier. And if we don't, again, we have to do with migrations. But once the application continues to grow in complexity, we see that all that work that we did early on actually pays off. Now, is there a way that we can have both? It would be ideal if we can start with documents, and if our complexity grows much more quickly, then we can switch into relational. But in such a way that we don't have to throw away everything that we did for documents and then suddenly switch to relational. So it would be great if we could do some sort of easiness into the migration that we do from one format to the other. So what we propose is to have both kind of formats from the get-go, from the first start. It's not that you do one and then later. You can do both from the first thing that you're doing with your application. So what we're proposing is that you can be effective with either of those formats once you get started with your application. In theory, giving you that productivity boost that we are aiming for. So you won't be delayed whether I use documents or relational. You just go. Just do your thing. Concentrate on delivering the features to production, and then don't think too much about what else is going on, because the database vendor is the one that is going to give you the support that you're expecting. So we call this feature the JSON document relational duality, or JSON relational duality views. And this is a way for you to define mappings within the document world and the relational world. You can do it in a couple of ways. The storage format continues to be relational, but the way that we expose the data will be document. If you were to say, Andres, what are you talking about? Reading relational data and exposing a document, that is quite simple task to do. Everybody can do this. Yes, obviously. But what if you take a document as an input and you want to insert, update, or delete the data? Someone has to be responsible of deconstructing the JSON document into the relational world so that we can do a proper insert, a SQL update, or SQL delete, and then magic happens. So who will be that one responsible for doing the mapping? Right now, we do it at the application level. But it would be better if the database provider would be the one doing that job, right? So there are a couple of ways that we can do it. We support a JSON format or a GraphQL format like this one. So in the mapping side that you have on that side of the screen is where we decide, hey, the root of our document is going to be the attendee, which happens to have these properties and happen to have relationship to other tables. So we can expose more than one table within the same document. In this case, we're going to expose the attendee, the session, and the speaker table, and there happens to be a mapping, so this is a joint table within the attendees and the session. So we're exposing 4 relational data tables in a single document. And just like that, just exposing this document for reading can also be done for writing. So you can insert a new attendee by sending a big document that happens to match the mapping definitions that we have in this screen. So right quickly, we can say that for the definition of this mapping, we have 4 tables. The names of the tables match the names of the elements that we have here. We have a way to define which relational columns we want to expose as document properties. So on the left side, underscore ID, name, company, those are the names of the JSON properties. AID, name, and company are the names of the columns. There is a shortcut version here where the name of one on the left is the same as the name of the right. Then you can specify only the name on the right, so name and company will have been enough. We can also tell the mapping whenever we receive a document, what do you want to do with the nested relationships? If you want to do an insert of a new attendee and you have a schedule associated with it because you have sessions and whatnot, what we want to do is ensure that that new attendee has a relationship to the existing sessions and speakers and whatnot. So this is not going to insert a new session, which is a nested object. It's going to insert a new row only on the attendee table. But if the document defines a relationship with existing elements, then those relationships will also be realized in the relational tables. We can also define these queries, this annotation to say the speaker property that happens to be deeply nested somewhere in our graph, we want to lift its properties to the element that is adjacent to the next level on top. So the name of the speaker will be seen as part of a property inside the session object. The advantage of this is that once you have this mapping, then you can create, you can produce, and you can consume these documents very easily. You can use SQL queries or you can use document queries. It's exactly the same in order to read, to update, to insert, to delete, all these things. Why are we doing this? If you are dealing with a lot of JSON content in your applications, the idea is that you only need to have a REST endpoint on top of your database so that you can send documents through those REST endpoints. It will be typically insert, put, post, get, and delete. So you send those documents and the database will react automatically. You can use a Spring Boot or Quarkus or Micronaut to create these endpoints very easily. There is another free tool provided by Oracle called ORDS, Oracle REST Data Services, that already exposes your database to REST. So if you have the database and RDS, it's just a matter of sending documents directly. And this little plumbing code that you have to write because it has already been provided by the free Oracle projects. Now, in terms of database software, you might be thinking, I need to secure a license for running this thing. Well, it depends, actually, because there are free versions of the Oracle database. This version is called Oracle Database Free. It was released first for developers last year. Early on, before anyone else had access to our software, we developers could use it. Now, the latest version is called 23 AI, was released in May of 2024, and that gives you access to the on-premise version and to the cloud version. But again, it's available for free. It has a new license that allows you to run this database in development environments, testing, and production for free. You can also run it for free on the cloud. And now that you may be saying, yes, we know there is an Oracle, there's a version of the Oracle database that run on the Oracle cloud. But we don't use Oracle Cloud Infrastructure. First, I would say, why not? There is a free version. But if you, obviously, you have other choices. If you want to run this database on other cloud providers, you can. Since last year, we have a partnership with Microsoft, so you can run it in Microsoft Azure. Since this year, in June, you can run it on Google Cloud Platform. And it was announced in September of Cloud World this year and should be available pretty soon. You can also run it on Amazon. So you can run the Oracle Cloud on multi-cloud for free. You can go to oracle.com/cloud/free to find out what are the different services and resources that will be available for you for free always. So as opposed to other cloud providers, I'm sorry I have to say it, we don't charge you after some sort of evaluation period. Once you sign up for the Oracle Always Free tier, you have access to these free resources forever and won't charge you any single dime about it. You can consume this on containers. There are other options out there to run the database. For example, there is the gVensel OCI Oracle free images that you can run on Docker, on Podman, or with test containers. This is if you want to use the latest versions, 23, that gives you access to JSON relational duality view. There are previous versions of the Oracle database called Oracle XC that runs from 11 all the way to 21, which you can also run on containers if you want to. I already mentioned test containers, and I hope that most of you use test containers. Yes, like half of the audience. Test containers is one of those technologies that changes your life, because this is how you can run your test cases with real databases. How many times have you been seen that I set up Oracle or DB2 or some other these enterprisey database providers, but I cannot run on my test cases because I don't have access to a license. So I'd rather use an in-memory database to speed things up, right? But then there will be some cases that cannot be tested because they are specific to the database features that you need to run in production. Well, test containers says, forget about that. Forget about in-memory databases or any fake or simulated software. Use the real software within a container that runs very close to your test cases. So if you do not use test containers today, at least one of the things that I would like you to take home today, have a look at test containers. It's going to simplify your life a lot. You can have access to many different containers as modules in test containers. Oracle Free happens to be one of those. So it's just one line of code and one dependency on Maven or Gradle for pulling out the classes, and off you go. It's as simple as that. I think we have, won't give me time to show you some code. I will try because this is DevOps. I have a Micronaut data application here where I can find objects through a JSON duality view. I can find a student through a given value. So this is just the name of the student. And notice what is the return value here. It's a string. This is the JSON document that is coming directly from the database. The same goes here. I can find an object, a document by an ID, and return the whole document as is, directly from the repository that understands talking to the database. There is no Jackson. There is no transformation of data through POJOs to JSON to go to the other end. It just grabs the document as is and then sends it to the client. It's storing a new student. If we were to use ORM here, this is your typical code. So we decode the JSON, the incoming JSON, then parse it into Java objects, our domain entities, use the repository, store it, and when it comes back, it's another object that gets translated into JSON by the framework. But if you were to use the JSON duality view, we take a JSON document as an input and then just send it directly to the database. Who is going to complain? Well, that would be the mapping. If we, for whatever reason, we make a mistake here, if we send a document that is not JSON, the database will complain immediately. You send me something that I don't understand. The next thing they will try to do is, hey, is this document comprising the structure that I expect? Yes, because it fits the mapping. Perfect. So it's as easy as this. So everything that we saw here today is you can come back to your teammates and say, hey, everything that I see in DevOps is nice, but we don't have time to implement this. Well, don't be discouraged. Talk to your teammates. What you saw today and the rest of the previous days makes sense. Find a way to talk to them, to demonstrate the new things that you have learned, do proof of concepts, and most of the times this will work out. There are some free resources that I have you, and I'm out of time right now, but thank you so much.